To find the equation of a line, we use the formula y equals mx plus c. To find the equation of a line, we use the formula y equals to mx plus c. Now, y is the value of any coordinate that you are going to use. Y is the value of any coordinate that you are going to use. Then m is the gradient. Then x is the value of x in the coordinates that you are going to use. Then c is what you call the y-intercept. C is what we call the y-intercept. Now, for you to find the equation of the line, firstly, you are going to need the gradient. If the gradient is not given. So let's assume in this case, the gradient is not given. So it means you'll have to calculate the gradient. Then you will also have to find the y-intercept. You'll also have to find the y-intercept. Now, you don't have to worry about the value of y and the value of x, because like I said, they are already given in the coordinates that you will be using. Now, let's take, for example, let's assume we have coordinates -1, 3, and 3, 6, 3, 6 as an example. So let's find the equation of the line that is passing through these points. So like I said, the first thing, we have to look for the gradient. And we know that to find the gradient, we use the formula m is equals to y2 minus y1 over x2 minus x1. So by now, I want to assume that maybe you know how to find the gradient. Then to find the gradient, I said label your coordinates, this set of coordinates, label them coordinates 1, then label these ones coordinates 2 to make life easier for you. And then remember that every coordinate has a value of x and a value of y. Every coordinate has a value of x and a value of y. So since the first coordinates, we have labeled them coordinates 1, so we can then label our x and y, label them 1, 1. Make them x1, make them y1, to make life easier for you, for easy substitution in the formula that we have. Then label these ones x2, y2. Then look for your gradient, or now do your substitution. Then substituting, the value of our y2 is 6. The value of our y1 is 3. The value of our x2 is 3. The value of our x1 is -1. So then solve this. Solving this, we get 6 minus 3, we get a 3. Then 3 minus -1, we get a 4. So it means your gradient is equals to 3/4. So you can express that as a fraction, or you can choose to express it as decimal. It is still okay. Now, you know the gradient of your line. Now you want to find the equation of your line. Then the next thing that follows is we go back to that formula that we said we are using when we are finding, or if we are finding the equation of a line. We said we use y equals to mx plus c. So you now have the value of m. It's 0.75. 0.75. So now you have to look for the value of c. Now, like I said earlier, the value of y and x, you already have them. You already have them. So you are going to choose one of those coordinates. You are going to choose one of those coordinates. I'll choose these coordinates. Then, like I said, every coordinate has a value of x and y. So then take that x and y and substitute them in that equation. So which means our y, if I use those coordinates, is going to be 6, and our x is going to be 3. So it means I have to rewrite this equation so that now I can find the value of c. So rewriting that, I now get 6 is equals to 0.75 times 3 gives me 2.25, then plus c. So we are solving for c. So we have to take everything this side, so that this side we are only left with what we are interested in, which is the c. So it means c is equals to 6 minus 2.25. And that gives us 6 minus 2.25 gives us 3.75. Now, you have the value of c. You have your m. M earlier on, we found it to be 0.75. Now, you go back to this equation, y equals mx plus c. And in that equation, you are now going to substitute the value of m and the value of c only. To finalize your equation or to finalize your answer, you are now going to substitute the value of m only and the value of c only in that equation. So it means your final answer now is going to be y is equals to 0.75x plus 3.75. That's the equation of your line. So that's the equation of your line. Then I'll do another example. Let's say we have 1, 4 and 1, 4 and let me say 2, 2, 8 as an example. So we want to find the equation of the line that is passing through these points. Then I said, for us to find the equation of that line, we are going to use the formula y equals to mx plus c. Then I said, from this equation, it means we need the gradient. We need the gradient. So we have to look for the gradient. And then we need the c, which is the y-intercept. Y-intercept. And y-intercept, if we were to draw this line in our coordinate plane, y-intercept, it is where your graph or where your line cuts the y-axis. It is where your graph or the line that you are going to draw, if you were to draw it, where it cuts the y-axis. Now, so we need those two values. So don't worry about the value of y and x for now. Don't worry about the value of y and x. So it means first things first, let's look for the gradient. Let's look for the gradient. So the gradient, we said for us to find the gradient, we said m gradient is equals to y2 minus y1 over x2 minus x1. Then I said, to make life easier for you, label these coordinates, coordinates 1, and label these ones, coordinates 2. And every set of coordinates has a value of x and y. Every coordinate has a value every coordinate has an X value and a Y value. So now, because you labeled these X1, because you labeled the first coordinate 1, now continue differentiating them further by labeling them to be X1, Y1. And then these ones, call them or label them X2, Y2. Then you now have your XY, you now have your X1, Y1, your X2, Y2. Now take them and substitute them into your equation so that you can find the value of M, which is your gradient. Now, our Y2 is 8, our Y1 is 4, our X2 is 2, our X1 is 1. Then solving this, we get 8 minus 4, we get a 4, 2 minus 1, we get a 1, and 4 divided by 1, we get a 1. So, which means our gradient is a 1. Our gradient is a 1. Then, the next thing then that follows is we have to look for our y-intercept. So, we go back to that formula. Y equals to mx plus c. We now have the value of m. So we want to look for the value of c. Now, to find the value of c, you have to pick one set of coordinates from those coordinates that you have. Pick one set of coordinates from these coordinates that you have. So I will choose to pick these coordinates. And then, like I said, every coordinate has a value of x and a value of y. So now take that value of x and that value of y and then substitute them into your equation. So it means our y in this case is 8 and our x is 2. Then remember the gradient that you got. The gradient that you got is 4. So it means you have a 4 here. So it means the only thing that you don't have is the c. So rewrite this equation. So rewrite this equation. So rewriting this equation, you are going to get, rewriting this equation, we are going to get 8 is equals to 4 times 2 plus c. Then this gives us 8 is equals to 4 times 2 is 8 plus c. Then solve for c. So it means we take this one, this 8 on the other side, or we collect like terms. So that this side, we are only interested in what we have, which is the c. So then this is equals to 8 minus 8 minus 8. And 8 minus 8 gives us a 0. So it means our c is equals to 0. Now, you have your value of c, and then you have your value of m. So take those values now and go back to your equation and substitute them into your equation. So substituting that, and remember when we substitute, we are only substituting the value of m and the value of c. So you leave out the value of y and x. So we are only interested in substituting the value of m and c, and that gives us y equals, our m is 4x and our c is 0. Mathematically, we don't write the 0, so we can just erase it. So it means the equation for this, equation for this line is equals to y equals to 4x. So that's how we do that. That's how we find the equation of the line.